That's right. Got it. So the bottom, I just need to be clear. We need to maintain the integrity of the exams and the course. So if you do choose to do some of that, that's your personal copies. Okay. All right, let's move on. Thank you for that feedback. So we're on day 4. Congratulations. You're past the hump day. So today we cover BigQuery both this morning and some of the afternoon. This had recently, I think in July, we had finished building this out, and we've got qualification exams for that as well. Cloud SQL is in the process of being built out, so you'll actually get some updated but hybrid version of it before a qualification exam is available for it. So at the end of the day, that's when there's 2 things that'll happen. One is I will administer the exam. Now those exam instructions are different for people who are internal, i.e. Motorola and Google folks. I've emailed you a copy of instructions. If you didn't receive that, come to me directly. For those of you that are partners, the rest of us, you will be given a presentation on what you need to do. Big picture. So just make sure that it's not confusing to the internal folks. You will basically schedule your exam to be delivered, to be proctored through your computer, your camera enabled computer. That's the gist of it. So you'll need a camera enabled computer to make it work. All right? What's that? External camera will work, yes. Yep, yes. The volume? Sure. Can you increase the volume a bit? Is there a way to increase the volume? We'll try also hold it closer. How's that? The voice of God. Okay. And tomorrow we'll end up with Compute Engine. So the one thing I want to let you know today at the end of the day, not only will I administer the exam instructions, so you'll be scheduling them during the next week, but I'll also be handing out blue versions of these shirts. Okay, so you'll want to hang on, and in exchange for that, what I'm asking, everything is tomorrow morning we will be taking a picture with everybody in this class with the instructors. So I want everybody to wear their bright, shiny new blue shirts, and for the class picture, you need to be here at 8:30, 8:45. The picture will be taken. Okay, I know a little hard of getting up, but I got it. Okay, you don't need to take a shirt, but okay. And here's the agenda. There are labs throughout, except for the advanced. There are, for the BigQuery Advanced, BigQuery Basics, BigQuery Developer, and then BigQuery Advanced in the afternoon. Cloud SQL and a pretty detailed lab. We suspect, from a timing standpoint, administration qualification exams will be around 4:30, and then we'll be handing out shirts after that. Yes? Yeah, that's tomorrow. So if you actually back up here, see on day 5, Compute Engine. Correct. The only subjects on the qualification exam are App Engine, Cloud Storage, and BigQuery. So by this afternoon, you'll have all the content you need, okay, which means those are the ones you should focus on completing the labs and understanding fully before taking the qualification exams, right? So Cloud SQL and Compute Engine is extra credit, not quite ready for qualification exams. Okay. Any other questions? All right. With that, I'm going to hand it over to Shiro. Shiro, you're on for BigQuery this morning. Now you get to be the voice of God.
All right. How are you, everybody? Good? Cool. So actually, before I start, I'm going to talk a little bit about tomorrow's computer engine lab. So does anybody decided, so who wants to use a shared project? Right? So everybody want to use your own, oh, you still want to use your, okay, can you send me your, email address to me, Shiro, Shiro, at google.com. And, saying add me to your shared project or something. Yeah, we can do that tomorrow, but it would be better to do that in advance. All right. So actually, how many people are familiar with BigQuery? Actually, we have a lot. That is good. I can be more relaxed with that. Okay, let's get it started. So, so we have 3 sessions: BigQuery Basics, BigQuery for Developers, and Advanced. And this is the first session. So this will be more introductory course. So this explains what BigQuery is. So this is going to be a BigQuery overview and typical use cases, typical uses, project hierarchies. That's going to be a more, how we use BigQuery. And the access control, security things, data set and tables, and tools and demos. Actually, instead of demo, we do an exercise. Okay, what is BigQuery? So in a single word, BigQuery is an analysis engine. So if you want to analyze huge data, usually terabytes or even more of the data, we're going to use BigQuery. And why we use a BigQuery? So MapReduce, how many people are familiar with MapReduce? Actually, more than I expected. So MapReduce is a distributed analysis system, which is originally developed by Google. And it is, original MapReduce is internal to Google, but we published a paper about that, and external people, the guy in Yahoo, developed the open source version of the MapReduce, which is now called Hadoop. I think probably many people have heard of Hadoop. But anyway, this MapReduce or Hadoop is not good for ad hoc queries. So if you want to quickly check something, MapReduce is not a good fit. You have to write mapper reducer programs and run that. And BigQuery is strong for ad hoc queries. And also managing the data center and tuning software takes time and money. If you have a cluster of Hadoop and you keep your data on Hadoop, well, Hadoop or maybe a SQL-based data warehouse, you have to maintain your cluster computers, and that's going to be costly. So analytics tools should be service, meaning you don't need to care much about your infrastructure. Actually, this is the same concept with the App Engine. We, Google, take care of all the hardware, OS patches, software versions. You don't need to worry about that. You just care your real business part. In case of App Engine, that's a logic that runs on App Engine. And in BigQuery, that's going to be the analysis you're going to do. So this is a common concept in cloud. So okay, so why we use BigQuery? So in general, if you maintain a data warehouse, as I mentioned, big data, maintaining the big data, we require physical servers and skilled database and administrators. And the interaction can be slow and inefficient. So actually, about 10 years ago, I was doing analysis on SQL. Actually, it was a PostgreSQL at the time. So it's not big data in today's scale, but it was still big at the time. So actually, one SQL took 20, 30 minutes. So after I start the query, I went out to lunch, come back from lunch, and I get the result I didn't expect, and look back my query, and I found out a stupid error, and I modified it and ran it again, but I don't need another lunch. But if you use a BigQuery, actually, most of the query finishes within a minute. So I don't even have time to get coffee out of the room. So that's big advantage of the BigQuery. So okay, so what's a BigQuery? So as I mentioned, the BigQuery is a service for analysis of the huge data. Huge or massive means terabytes of the data, or even more. And so it may have billions of rows, and we only take seconds, maybe 10, 20, 30 seconds for analysis. And we use a SQL-style query syntax. Well, I know many of you are already tired of the SQL-like syntaxes, but this is one of the standard. And the reason we use SQL is that this is for analysis. And if you look at external people, data analysts, they are very good at SQLs, but they don't write any code like Python, shell script, Java, C. So SQL is the most familiar language. And it's a service. And so we have several ways to access. One of them is a RESTful API. So you can, if you want, you can write a program that issues the RESTful API access. And it's reliable and secure. So BigQuery is externalization of Google's internal system called Dremel. So Dremel has been used for a long time, for years, to analyze the log inside Google. So it's reliable and secure. And so, we basically use the same infrastructure. So if you upload your data, ingest your data into BigQuery, that's replicated and will be secure and scalable. So hundreds of terabytes. That's huge. And the good thing is pay only for what you use. So we charge for your data storage and for how much data you processed. So even though, yes. So the question is if there is a charge for transmission of the data, and the answer is no. We only charge for storage, how much data you have in BigQuery, and how much data you processed, meaning how much data was touched by your query. The question is charge related to cloud storage. Right. So if you, well, we're gonna talk about it later. But so you can ingest the data directly from your machine or from cloud storage. And if you use cloud storage, once your data is ingested into BigQuery, you can delete the data on cloud storage if you don't want to be charged. Did I answer your question? All right. All right. So this is a summary of the summarized slide. So the BigQuery is the analysis engine for the large amount of data in high speed. Any questions so far? Yes. how often Google uses BigQuery. So do you mean internally? Yeah, so internally, most of the people use Dremel instead of going to a BigQuery. But I don't know actually how many people uses Dremel, but it's very frequently used. So actually, before I joined this cloud team, I was working on Google Maps, and daily use Dremel to analyze which query is more popular to prioritize a project. Oh, it's probably you don't need to worry about that. I don't think you can hit the limit of the BigQuery. Well, although we do have some quota, so that to avoid abuses. So here is some typical use cases. So analysis of the query's result with a visualization. So BigQuery itself is basically SQL-like language. So the data source is something like a table, and the output is also something like a table. So that is not really intuitive, but there are many ways to visualize it so that it's going to be more convincing. So this is an example, average baby weight in 2000. Well, I don't really know what it means, but but one thing I noticed is in Alaska is has bigger baby, or in general the colder area seems to have the bigger baby. This is very intuitive. But if you have the table of the five entries, you may not really get idea. Or another way is to export the result, or ingest the result into a Google spreadsheet, and where you can have more analysis, like making a chart. Yes. Yes. Right. So I'm not really familiar with how many laws it supports, but BigQuery itself also has a limitation in the output data size, like 64 megabytes or 120 megabytes. I'm not really sure. It's expanding year by year, actually quarter by quarter, but so I know I didn't fully answer your question, but. So that depends on the use case. So one good use case about the visualization is to create a report, like for example, the sales per year, per month, or per quarter, and you can make a graph for that. So the big data is huge, so it's really hard for people to understand. But the BigQuery helps you analyze, meaning it reduces the size of the data so that people or human can understand. Right? Right, exactly. Mm-hmm. I'm not sure if BigQuery is good for that the streaming use case because our streaming we just released the streaming capability, streaming ingestion into the BigQuery, but the amount of the data is limited to 100 rows per second or something. So I'm not. So I kind of doubt if this streaming case is a good use case of the BigQuery. So here are some examples of the BigQuery use cases. So if you go to our clients, log analysis is one of the biggest usage. So the log maybe from web server or from your backend server for your Android or iPhone, or it may come from many servers. And many customers combine these logs into one table for the analysis. And the retailer, the product sales. So in this case, the data comes from POS system, and the sales is sales data will be huge, and so they can analyze this, the sales trends or or whatever. Ads targeting, so ads targeting in on web server on web service is will be a huge data, and sensor data. So you can set a sensor on your corridor or your room. So actually in our Google I/O we set up sensors in our in the Moscone center. And we collected the data, and we showed how a BigQuery can analyze the data. But again, it's not really real time. Data mashup, query terabytes of heterogeneous data. Actually, I'm not quite sure about this use case. But if you have a multiple data source, you can maybe somewhat combines data. So one example is if you have different servers. Well, that's connected to the first example. But if you have a multiple servers, you can combine into one table for the further analysis. And yes. Yes, I'm gonna talk about the format later. The question is how. So where the data sets? So you have to ingest your data onto BigQuery. So it may be on your computer, or it may be on cloud storage. But before you analyze the data by BigQuery, you have to ingest the data first into BigQuery. So here are some customer cases. So Blue Box uses BigQuery for ads. And second one, Red Bus uses a dashboard for booking and inventory data. So actually, if you're familiar with inventory management, actually that's a big problem. You might have a lot of. So you have to combine the online technology with the offline technology, because the number of some physical stuff may not be correct. But in any case, if you are handling many inventories, a lot of inventories, the inventory and management will be a big thing. And Cloudlytics uses BigQuery to expand game engagement. So this is used for game analysis of the users. In online games, a lot of people plays games simultaneously, and they want to analyze and optimize their monetization. Crystalloids uses BigQuery and App Engine and Visualization API to build a business intelligence solution. Actually, I'm not familiar with this case. Okay. Any questions so far? So here, this is the end of the, what is BigQuery? All right, what is BigQuery? Yes, oh, sorry, before that question. Mm-hmm. Mm-hmm.
So it's not ad hoc analysis that they change the criteria and look at or visualize. It's basically the same reports over and over, newer data. Would that be a good use case for, I mean, they have these traditional dimensional models behind and, but it's like here we need flattened views and all of it. So I don't know, is that a good use case for BigQuery?
So I think that, so the question is, traditional BI tools has a reporting mechanism, and what's going to be the, say, relationship or advantage, whatever, of the BigQuery against the BI tools. So I think the answer is they are complementary. So if you need, so there are cases you need a regular report, like monthly sales or monthly sales by category or monthly sales by geographical locations. BI tools are very good for that. But in addition to that, you might want to do some more ad hoc analysis. You might so for example you have a data per state, but you might hit the idea, how about the difference between the Northern California or Southern California, or you might, do some more, I don't have good, yeah. Those, ad hoc analysis is, the strongest thing in BigQuery. Yes, correct. Yes, correct. And also, BigQuery has we have many third-party tools who supports visualization. So if you want, you may you can create something similar to traditional BI things on top of BigQuery. All right. Any questions? Clear? What is BigQuery? Are you guys really sure? Anybody? All right, cool. That's perfect. All right, so let's go into a little deeper into BigQuery. Right. Here how BigQuery looks like in a logical sense. So project, when we call project, this is a Google Cloud Platform project. And so this is the same project as you have for cloud storage or compute engine. So one project may have a cloud storage enabled or BigQuery enabled. This is the same project we mean in here. And data set is set of the tables. So you can combine multiple tables, or it's kind of a bucket where multiple tables can sit inside. So you may want to categorize the data or tables into multiple data sets. And table is table in the same sense as SQLs. And job is query or data ingestion into BigQuery. So in this figure, project is a top layer, and the BigQuery has multiple data sets, and one data set may have multiple tables. And the job makes query or ingestion into BigQuery. And the project can set access control. Who can see your data? Who can modify your data? And this is the data sets and tables. So on the right-hand side is a part of the BigQuery Web UI. So if you look at here, we have several data sets. So actually this public data and Google data are the public. And if you just turn on BigQuery, these data sets are already here. Somebody have a question? So the ACL is set by project level. No, I don't think so. Oh, okay. Lowest access control unit to which ACLs are applied. It seems so. Sorry, I haven't used this. Actually, I'm not quite sure. I'll come back to you later. Okay. So here is how we. Yes. So these are the data sets, and this is how we specify the data sets in query. In the current project, you can say just dataset.table name, and in a different project, so this is going to be the full name, project : dataset.table. So in this case, public data actually sits in a different project. So if you want to specify the public data or Google data, you have to specify the project name. So data structure. Has anybody heard about columnar database? Quite a few people. Yes, so I think the columnar is one kind of a buzzword right now. A lot of, including this BigQuery, a lot of provider or open source project claims for columnar database. So what it means is so the inside, so on the right, small one, this is the regular way to store the data. So each row is row is a unit of the data. But in the columnar database, if you have field 1, field 2, field 3, these and we have 4 or more rows. These data are split per column. So this chunk of the data contains only the field 1. This contains only field 2. This contains field 3. So this is what happens when you ingest your data into BigQuery. So BigQuery, so you can ingest CSV or JSON files. But when you ingest the data into BigQuery, BigQuery splits your data per column and store the column in a separate way. So the advantage is even though you have many fields, if you query for only the first field, this is the size we say you touched. That means the data size you are charged for. And the good thing about this is that you don't need to set an index in advance. In the relational database, you need to set an index in advance for the first-time access. But the drawback is if you want to analyze by the field you didn't expect before, first you have to set index. It takes some time to build index, or you have to wait for a while. But how it works here is actually this is not a single file. Internally, it's split into multiple files, and we don't need index, but we use multiple hundreds or thousands of machines to analyze this column. So we don't really need to set index. So when you ingest the data, you just ingest the data and then run query. You don't have any additional configuration. Internally non-index, no. Internally, no. That column is all the data. Or of course, we have a complex system in the server side. All right, so here is an example of the schema. So so this is different from data store. You need a schema. So in this example, you have 3 columns, 3 fields. The first field name has string, second field gender string, and third field third field count. This is integer. So this is explained in this way, and we use this for data ingestion. And we support these data types: string less than 64 kilobytes, integer 64-bit sign, float, boolean, timestamp. Timestamp is relatively new. And the one thing is max row size is 64 kilobytes. So of course this string is must also be less than 64 kilobytes. Yes. Float. I think it's a double. I think double is. I'm not double should be 128 bits. Is it? I'm not sure. Yeah, I'm not sure. Sorry. Does it? Is there any case it matters? Oh, maximum number of the float field. Yes. Yep. Correct. Does that include repetitive? Yes. Repeated fields. Right, correct. In that case, if you need a lot of repeated fields, you must flatten in advance. Right. Yes. So the question is why we don't have just date type, and I'm not really sure about the reason, but we provide a lot of functions that manipulate the timestamp. Well, so performance-wise, I'm not worried too much about that because anyway, it's gonna finish in 20, 30 seconds. Hmm? Well, so one thing is, timestamp is actually a very new feature. It's only launched this March. So, I don't know why we don't have date. All right, so data format for ingested data. So BigQuery can ingest either CSV or JSON. BigQuery can load data faster. Supports nested repeated field. Yes. If you need a repeated field or nested field, you have to use JSON because there is no way for CSV to support some multiple values. And the actually, I think that's for CSV. So in CSV, one line can contain end of line if that field is enclosed by double quotes. But that is not recommended because there we can't really parallelize the ingestion. So if your field don't include new line, that's gonna dramatically makes the ingestion much quicker. So here is a actual repeated field and nested field format. If you specify, so this is a schema, table schema for the JSON. And so, so here is a nested field. So this one field contains country and city, both as string. And this nested field can be repeated. And this whole field, this whole field name is specified as location. And type record indicates this is a nested field. So when we use JSON data format, we need this kind of another JSON that specifies the data format. Oh, okay. So in a traditional or regular relational database, you can have only up to one value for one field. So for example, if your data is kind of, say, name, city, country, for example, you can have only one city for you. If you, say, lived in 2 cities and you need 2 fields, usually we want to split out into different fields and specify the relationship. This person has this city and the same person has that city. But in BigQuery, you can have repeated field, meaning this one person in one row, this person can have this city and that city. That's a repeated field. Or another example is suppose we have a family table and one person may have multiple children in a same table. Yes. Okay, so the question is how we know which one is repeated. So in this case, this level is repeated. So this is a nested field. So this country and city are nested, and that nested field is repeated. So it's not, you can have multiple cities, multiple countries or multiple cities. You can have pairs of country and city. Yes. Okay, so in JSON, so the question is a new line with a JSON. In JSON format, we use one line as a one JSON entry. So you always have end of line at the end, so we can parallelize ingestion. Yes, you can say that that's a subcolumn. Repeated means you can have multiple values in a one single row. Yes, correct. So in this example, it's like a structure or internal class in your object-oriented language, and you can have the array or list of the internal classes. Use case or mhm. Oh, okay. I think it's good to use. Uh-oh. So in that example, actually, does everybody see this whiteboard? Okay. So for example, we record where you lived so far. So this person A, okay. So this person A have lived in, say, city, country, and city Mountain View, USA. And so this is, so in that example, actually, what happened? Okay, so in this example, this city and country is a one unit of the data. That means this is nested field. Okay. Location.city and location.country. So this has a this kind of a class or structure has a name location in this example. So the name will be location.city, location.country, meaning country, city as an internal member of the location. And this is repeated. That means you can have multiple values. So before, so actually, what? So in more Python case, it's gonna be like no, it's still an array. You still have the array. So this is repeated, meaning you can have multiple values for this case. So this person lived in Tokyo, Japan before. No, this is repeated. It's more like an array or list. Mm-hmm. Yes, correct. Or you can pick up the people who ever lived in Japan. In that case, if this person have Japan in one of the repeated fields, it's going to be picked up. So we're going to cover about how this repeated field works in the next session. So it seems a repeated field is a difficult concept, or it's maybe very unique to BigQuery and not common with relational database. Okay. Any other questions? Or are we ready to move on? Hmm? Oh, actual values. Hmm. Okay. So here are several ways to access BigQuery. We're going to talk about how to access the BigQuery more in detail in the next session, in the developer session. But one first way is a web browser. If you go to BigQuery, the cloud.google.com, you have a web browser. And the BQ command line tool, so you can run a command from your command line. That's going to be a very good way for convenient for shell script or the scripting languages or service APIs. BigQuery supports REST API, and as usual, the authentication is made by OAuth. And for this API, you can use the Google Client API libraries for these languages. I'm going to cover this in the next session. And we have an exercise for this. And here are some third-party tools that can be combined with BigQuery. So actually, many of our customers use external third-party tools for data ingestion and visualization. So, so the first part shows a list of the ETL tools. So how you ingest your data into BigQuery. And second, these shows a visualization tool. So it's more querying and showing the result. So this is an example of the visualization tool. So in this case, the original data, so this is from BIME, and the original data is from BigQuery. And with this, very user-friendly UI, it can create a chart, bubble charts, and you can create report. And I think this is your console, how you can configure these charts. And loading data is actually the hardest part for BigQuery, how you load the data. So you can either upload from your local disk or from cloud storage. So if we start from the web browser, select dataset, which dataset you want to have your data in. And then we have a wizard on our website, on our web browser, web UI. And another option is use a BQ tool. So from command line, you can do BQ load. BQ load, and it specifies a table and the data source URI and table schema. So it can be either CSV or JSON. Is this clear? Maybe this you might want to go to our website for more detailed reference about BQ tool. So as I think somebody raised about the limitation. So we don't have any limitation in the total data size you can store in the BQ. Maybe your budget will be the limitation. But other than that, we have some restrictions: 1,000 import job per table per day, or 10,000 per project per day. So it's not it's not realistic if you want to ingest data every second, a few rows in every second, because that's gonna hit the limitation. or the file size for limitation. So when you upload CSV or JSON, you can compress the data. But if you use compressed data, each file must be less than 1 gigabyte. If it's not compressed, it's uncompressed, the data's limit is 1 terabyte. However, if you use new line in strings in CSV, it's going to be 4 gigabytes. So I think the JSON, uncompressed JSON or uncompressed CSV without new line will be a good option if you have large file. And 10,000 files per import job. So that means you can specify multiple files. And the one file is limited to this size. And the number of the files is limited to 10,000. And the total size per import job is 1 terabyte. I know this is complicated, but sorry, come back later. Yes. Second and fourth. Oh, this one and this one. Okay. Okay. There's question difference between this one and that one. So the first one is number of the jobs you can do. And this one is a number of the files per single job. Right? No, we don't have the max for concurrent jobs. Unless you do crazy things. Which one?
So the file size limitation. This is the file size in the single load process, but this is not limitation in the final table size. So for example, I can load one table.
Correct.
1 terabyte this day and 1 terabyte again tomorrow.
Right, correct. So this is a limitation for your load. So if you so for example, if you have two 1 terabyte files, you can issue 2 load jobs. That's totally fine within the same day. Data is no, it doesn't really matter. No, we don't really matter. So actually, when we ingest the data, it's split per column, and it's split into a size which is suitable for processing. So actually, the order doesn't matter, and we don't guarantee about the order in the result. Every column, every data in the column. We read all the data. So getting closer to the end of this session, few best practices. So if you have a data that's larger than 1 terabyte, there is no direct way to ingest. But one thing you can do is you can split the data, and you can just use a split Linux split man with line bytes option. Or Mac, you can install GNU split. And another good use is use a cloud storage. So you can do either direct import from your local machine to BigQuery, or you can first upload to cloud storage and then into BigQuery. But actually, when you process the data from cloud storage to BigQuery, it actually takes time because you have BigQuery have to process per split per column, and then you splits the data to good size and distribute for the further processing. So if anything wrong happens here in the ingestion process, if you go directly from your local machine, you have to upload again. And so we recommend people to first upload to cloud storage and then go to BigQuery. Usually this connection is built in Google, and so you don't need to worry about the bandwidth of the network. And also we recommend to split the data into smaller size. And good use is if you have large data, for example, sales data, it would be great if you split the data per month or per day, depending on the size. The reason is, let me finish. Yeah. So the reason is BigQuery is append only, so that you can't really modify the existing data. So after you upload all the data and you notice some error, the only thing you can do is drop the full table and do it again. But if you have smaller tables like per day, if you find out an error on certain day, you just drop one day and you reload for the one day's data that should be smaller. So one way is maybe set up the cron job, and in the cron job use a shell script to pick up the date, today's day or previous day. Oh. Correct. So at this point, we don't have star in a table. But you can use multiple tables from 2013. Great question. I'm not saying anything about that. All right. Oh, yes. Oh, sorry. The question was if we split the data per day or per month, it may end up with many tables. And for the analysis part, the user must change the table name for, say, each day or each month. And if there is a better way for BigQuery to handle it. And the answer is at this moment, we don't support like select something from blah, blah, blah star. But we can specify the multiple tables if you want. So, there are pros and cons in splitting the data. If your data is small enough to be combined, say, per year, that's totally fine. But the drawback is, say, if you store 1 year data in a single table, but most of the time you only pick up, say, the last month's data. You still have to pay for your processing of the whole column data, even though if you are filtered out by where condition. All right. Yes. No limit on those table size. Correct. Okay, the question is what happens if you put everything into the one big gigantic table. So the table size is not a problem. We don't have any limitation for the table size. The problem is if you find out an error in your existing data, and if you really need to fix it, the only thing you can do is drop the table and re-ingest everything. That's one thing. Another drawback is we charge by how much data you processed. So if most of the time you just filter out recent 1 month data, we still charge for whole for whole data. Yes.
If I say query and then just where date equal to date.
Yes, correct. But
Only charge for today's data.
no. To filter, we have to scan. Yes.
The charge issue would still be there, I guess, because you are scanning through. Because one of the problems going forward, what people saying is we have a situation where data gets loaded every week, so we have tables for every week. When the user comes to the actual do ad hoc query, it doesn't know how many weeks of data is really loaded, so it just ends up taking one table and just running the query.
So the question is, even though if we have multiple tables per week or per month, for example, user might be still charged against the whole data. The answer is you can specify which table you want to scan. So if you so in that case, a user will most likely specify the latest column, which latest table, which includes all the 1 week data. Not necessarily. So for example, if you have a per year data, if you accumulate 10 years of data, and most of the time you are looking for the latest last year's or this year's data. Yes, if you want to compare 2 years, or if you look at the trends for 10 years, you are still charged. And if that's most of your use case, it's still good to have everything in one table. But most of the case, you more look for the recent data than 10 years old data. That's a point. All right. So this is a few best practices. Split the table. We discussed a lot about this. Upload multiple files on cloud storage. Right? If an error happens, this is going to make it easier to recover. And denormalization. So we're going to cover about the table join in the next session, but we have some limitation, and rather than having multiple tables, denormalize before you ingest is a good idea. We're going to talk about this in the next session more. All right, so this is the end of the presentation. Any questions? So if you are fine, yep. Okay. All right. So this exercise is very introductory. So it's more for those who haven't used BigQuery to get into the BigQuery. So enjoy.